Hi, welcome back to MEEN 221. Today we are going to look at another example of friction, in which case, in this particular case, it's a more complicated thing. You have two blocks A and B which are wedged together and a force P is being applied. The weights of block A and B are 1000 pounds and 100 pounds. So this is 1000 pounds, that's the 100 pounds. If the coefficient of friction is 0.3, so there are three surfaces, 1, 2, 3. There are three surfaces and the coefficient of friction is 0.3. What we want to figure out is how hard should I push on P on the block so that it moves. So I want you to understand that when it starts moving, this is going to go like that. This is going to go like that. So that's what will tell us which way friction forces should be selected. Okay, so always start with this idea of making your best guess as to which way things are going to go. So you can see that in this surface, the sliding is going to be like this. And on this surface, the sliding is going to be like that. And on this surface, the sliding is going to be like this. Right? That's what we really need to know so that we know which way things are going to point. Okay, so off we go. We are going to draw the free body diagrams for these two things. So please remember, the best way to learn this is for you to do it. So what I want you to do is draw the free body diagrams for the bodies A and B. Pause this thing, go draw it. Come back and take a look. This is the best way to learn. Okay. So did you pause? Have you drawn your free body diagram? So now I'll show you what I have. For body A, this is the free body diagram that I have. So the 1000 pounds is obvious. The normal force N1 is obvious. So popular mistake is to always automatically put N1 equal to 1000 pounds. It's not. You have to use Newton's laws to figure it out. The friction force is pointing this way because of the slip is that way. Can you see? So the friction force direction is opposite to slip. There is a normal force N2 between these two blocks. That's N2 there. And there's a friction on this block pointing down. Why is it pointing down? Can you see that this body B is going to slide down? So it's going to rub on it, and when it tries to rub on it, it's going to drag, it will try to drag A downwards. So that's why you got a friction force down. So this is very tricky. So please pay attention to this free body diagram. Stare at it for a long time. Notice this arrow is always opposed to this arrow. This arrow is always opposed to this arrow. So this arrow system is very important. If you make a mistake, you will have to be very careful at the time of calculations. And you don't want to do that. Okay, so this is free body 1. Free body 2 is here. So I have N3, that is from the wall. I have friction force 3 pointing up. Can you see? This arrow is down, so that arrow is up. Friction force F2 is the opposite of this. So these two things form an equal and opposite pair. And so you will see that the normal force is equal and opposite, friction force is equal and opposite. That's Newton's third law. And if you guess the friction force on one of them, the other one will be opposite. That's the easy thing to do. Okay. This free body diagram is really important. So what I want you to do is pause it, stare at it, figure out which way friction is for every one of these blocks. This is a hard problem on the free body diagram side. The rest of the stuff is pretty easy. Okay. So this thing is 72 degrees and I marked the 72 degrees there and all the other angles are marked. So off we go. This is 100 pounds. Okay. So off we go. We are ready to solve it. All the coefficient of friction are 0.3. Okay. So let's set up the equations of equilibrium. I'm going to set it up for each side. So summation of all the forces in the x direction. Let me use a black color. Summation of all the forces in the x direction. This way positive equal to 0 gives me F1 minus N2 equal to 0. That's equation 1. Summation of all the forces in the y direction equal to 0. This way positive gives me N1 minus 1000 pounds minus F2 equal to 0. Okay, now you go here and you say, okay, summation of all the forces this way is positive, gives me N2 minus N3 cos 72 degrees. You gotta get these angles right, so stare at it and figure it out, okay? Sorry, cos 18 degrees, not 72 degrees. This angle is 18 degrees. Plus F3 cos 72 degrees equal to 0. Summation of all the forces in the vertical direction gives me minus 100 plus applied force P, minus P, minus P plus F2 plus F3 sine 72 degrees plus N3 sine 18 degrees equal to 0. So this is equation 3 and 4. So now it's time to count. There are 4 equations. Unknowns are F1, F2, F3, N1, N2, N3, P. Seven unknowns. So I need 3 more assumptions. And the 3 assumptions come from minus mu n1 less than or equal to f1 less than or equal to mu n1, minus mu n2 less than or equal to f2 less than or equal to mu n2, minus mu n3 less than or equal to f3 less than or equal to mu n3. So I have to look at the situation of impending slip, whether I am going to put this one or this one, this one or this one, this one or this one. So if I assume body A goes this way and body B goes that way, which is our, if I want to push hard on P, it's going to go that way, right? So if I assume that, then the correct ones are this. Those are my 3 additional assumptions. F1 equal to mu n1, F2 equal to mu n2, F3 equal to mu n3. So let us see if we can solve for these 3 things, okay? So if I put, so our assumptions are F1 equal to mu n1, F2 equal to mu n2, F3 equal to mu n3. So these are my additional assumptions. Okay, if I do that and I substitute it in the first equation, I'll get mu n1 minus n2 equal to 0, n1 minus 1000 pounds minus mu n2 equal to 0. So this will give me, this is substitute into 1, substitute into 2. Now this will give me n1 equal to 917.43 pounds, n2 equals 275.23 pounds. Okay, now take this, substitute into equations 3 and 4. So I will get 275.23 pounds minus n3 cos 18 degrees plus mu n3 cos 72 degrees equal to 0, minus 100 minus p plus 0.3 times 275.23 pounds. This mu is 0.3 plus 0.3 times 428.71 pounds. So, oh, I'm sorry, this one is n3. You can solve for n3 and this turns out to be 428.71 pounds. So take that, this is equation 4, 3 becomes this, equation 4 becomes this. So if you did not actually write this down and follow with me, you wouldn't see how I got this. Okay, so please write down the first 4 equations that we wrote, 2 for this free body diagram, 2 for that free body diagram, and then come and take a look at these things. Otherwise you will not follow what the heck the calculations are. Okay, so please do that. Okay, so 428.71 pounds sine 72 degrees plus 428.71 pounds sine 18 degrees equal to 0. So this will give me P equals 236.04 pounds. So this method, so it's actually depends upon drawing the free body diagram correctly, figuring out how many assumptions you have to make and make those assumptions here. And then the rest of the stuff is just routine algebra. There's nothing more to it. Okay, so that's the trick. Thank you.